When Sophia, a Saudi Arabian robot, has become the first machine of its kind to be given citizenship of a country, this was an example of how robot technology and artificial intelligence will make machines more human-like in the future. Artificial intelligence is a technique of enabling computer or a software think intelligently. It is a branch of computer science that think intelligently to react like humans. Artificial intelligence can be achieved in two ways: through machine learning and deep learning. Machine learning provides artificial intelligence with the ability to learn and adapt and solve problems on its own based on some algorithms. Deep learning, whereas, makes it possible for artificial intelligence to function like a human, and probably even a more intelligent version of a human. It imitates the functioning of a human brain to make decisions and complete a task. The history of artificial intelligence is quite interesting and started around 100 years ago with the Dartmouth Conference. In 1956 there was probably the first workshop of artificial intelligence, and with it the field of AI research was born. Researcher from Carnegie Mellon University, CMU, Massachusetts Institute of Technology, MIT, an employee from IBM met together and founded the AI research. In the following years they made huge progress. 21st century, deep learning, big data, and artificial general intelligence. In the last 2 decades, artificial intelligence grew heavily. The AI market, hardware and software, has reached $8 billion in 2017, and the research firm IDC, International Data Corporation, predicts that the market will be $47 billion by 2020. This all is possible through big data, faster computers, and advancements in machine learning techniques in the last years. Let us understand now what is an intelligent agent. An intelligent agent is a software program that supports a user with the accomplishment of some task or activity by collecting information automatically over the internet and communicating data with other agents depending on the algorithm of the program. Intelligent agents play an important role in e-marketing and enhancing the e-commerce aspect of an organization. It enables both buyers and sellers in e-commerce transactions by providing efficient, precise, and enhanced comprehensive searches on the web and information repository. Intelligent agents are very interactive and can perform multiple tasks at a variety of locations. They are very powerful and versatile than traditional search engines, spiders, and web crawlers. Machine learning is often split into 3 perspectives: supervised learning, unsupervised learning, and reinforcement learning. A supervised machine learning system needs labeled data to develop a useful understanding, which we call its model. For example, given many photographs of people and their recorded corresponding ethnicity, we can train a model to classify the ethnicity of a never-before-seen individual in an arbitrary photograph. Simply put, a model is a function that assigns a label to some data. It does so by using previous examples, called a training dataset, as reference. Unsupervised learning is about modeling data that comes without corresponding labels or responses, test data that has not been labeled, classified, or categorized. The fact that we can make any conclusions at all on just raw data feels like magic. With enough data, it may be possible to find patterns and structure. Unlike supervised learning, where training data is conveniently labeled by a teacher, reinforcement learning trains on information gathered by observing how the environment reacts to actions. In other words, reinforcement learning is a type of machine learning that interacts with the environment to learn which combination of actions yields the most favorable results. Regression and classification are both related to prediction. Both belong to supervised learning, and in some cases those are overlapping also. For example, the price of a house, depending on the size and say location of the house, can be some numerical value, which can be continuous. This relates to regression. Similarly, the prediction of price can be in words, viz., very costly, costly, affordable, cheap, and very cheap. This relates to classification. Classification is the problem of identifying to which of a set of categories a new observation belongs, on the basis of a training set of data containing observations, or instances. If a question requires answer in yes or no, these kind of problems in machine learning are known as classification problems. For example, spam detection in email service providers can be identified as a classification problem. Classification belongs to the category of supervised learning, where the target's also provided with the input data. Regression is a technique used to predict values of a desired target quantity when the target quantity is continuous. In another word, regression is applied when the class to be predicted is made up of continuous numerical values. Regression means to predict the output value using training data. For example, refer the below picture. Estimating the price of a house. A classification model predicts discrete. Discrete means individually separate and distinct values, whereas a regression model predicts continuous values. Unlike classification, regression predicts a value based on past data, rather than classifying them into different categories. Classification predictions can be evaluated using accuracy, whereas regression predictions can be evaluated using root mean squared error. Regression analysis is a form of predictive modeling technique which investigates the relationship between a dependent, target, and independent variable, predictor. Regression analysis is a powerful statistical method that allows you to examine the relationship between two or more variables of interest. This technique is used for forecasting, time series modeling, and finding the causal effect relationship between the variables. There are in fact several different types of regressions, each with their own strengths and weaknesses. This choice often depends on the kind of data you have for the dependent variable and the type of model that provides the best fit. Linear regression, polynomial regression, ridge regression, lasso regression, and elastic net regression. Linear regression, also known as ordinary least squares, OLS, and linear least squares, is usually among the first few topics which people pick while learning predictive modeling. In this technique, the dependent variable is continuous, independent variable can be continuous or discrete, and nature of regression line is linear. Linear regression is a simple yet powerful supervised learning technique. The aim of linear regression is to identify how the input variable or explanatory variable influences the output variable or response variable. A linear regression refers to a regression model that is completely made up of linear variables. Let us see example of linear regression in the below graph, which is showing a measure of how much air somebody can forcibly exhale from their lungs, and x equals age in years. Linear regression with one variable is used when you want to predict a single output value from a single input value. That means you only have one x as input or attribute, and one y as output. Linear regression is an approach to show the relationship between independent variable x and dependent variable y. Example of linear regression with one variable. You want to predict the cost of road construction for a given distance. Given your input data, how can you predict any house price outside your initial data? For example, how much cost is required to build a road of 30 kilometers? Linear regression will help answering that question. You shrink your data into a line, with a corresponding mathematical equation. If you know the equation of that line, you can find any output, y, given any input, x. Model representation. Let us understand this by taking an interesting example. The globe of the Earth does not show every detail of it, but this small model can be put on our desk and it can give us an idea as to how the Earth looks like. When we talk about machine learning model, it is similar to that. It represents the data that is used to build it. Linear regression tries to fit points to a line generated by an algorithm. This optimized line, or the model, is capable of predicting values for certain input values and can be plotted. How data model works. At the beginning, when we have some data, usually we split it into training data and test data. We provide the initial training data to a machine learning algorithm that in turn builds a model. Then we use the test data to check how this model is performing and tune the model, as and if required. The model can be further updated, say, periodically, when more data is gathered. Let us take an example. To hire an employee, based on designation and experience, we shall like to know the cost to the company. Given designation and experience, we can find out cost to the company by using the above formula. That formula is called the model. A cost function is something you want to minimize. In another word, a cost function is defined as a function that maps an event or values of one or more variables onto a real number, intuitively representing some cost associated with the event. For example, your cost function might be the sum of squared errors over your training set. Gradient descent is a method for finding the min of a function of multiple variables. So you can use gradient descent to minimize your cost function. Difference between a cost function and a loss function. The loss function, or error, is for a single training example, while the cost function is over the entire training set, or mini-batch for mini-batch gradient descent. Gradient descent is one of the most popular optimization algorithms used in machine learning. Gradient descent is an optimization algorithm used to find the values of parameters, coefficients, of a function, f, that minimizes a cost function, cost. Basic understanding of linear algebra is necessary for the rest of the course, especially as we begin to cover models with multiple variables. A matrix is a two-dimensional array of scalars with one or more columns and one or more rows. We can represent a matrix in Python using a two-dimensional NumPy array. A NumPy array can be constructed given a list of lists. A vector is a tuple of one or more values called scalars. In another word, you can think of a vector as a list of numbers. A NumPy array can be constructed given a list of lists. Vectors are often represented using a lowercase character such as v, for example, v equals v1, v2, v3, where v1, v2, v3 are scalar values, often real values. What if your input has more than one value? Let us see how linear regression can be extended to accommodate multiple input features. Multiple linear regression is simple linear regression, but with more relationships. This is quite similar to the simple linear regression model we have discussed previously, but with multiple independent variables contributing to the dependent variable and hence multiple coefficients to determine and complex computation due to the added variables. Jumping straight into the equation of multivariate linear regression. Linear regression with multiple variables example. Predict the price that a house will sell for. The difference this time around is we have more than one dependent variable. We're given both the size of the house in square feet, and the number of bedrooms in the house. Polynomial regressions are often the most difficult regressions. When we want to create a model that is suitable for handling non-linearly separable data, we will need to use a polynomial regression. In this regression technique, the best fit line is not a straight line. It is rather a curve that fits into the data points. This is a technique for computing coefficients for multivariate linear regression. In the linear regression tasks, the normal equation is widely used to find optimal parameters. Normal equation is an analytical approach to linear regression with a least square cost function. We can directly find out the value of theta. Theta is a Greek symbol used in math. It does not have a specific meaning. Its meaning is often defined by its usage or context, without using gradient descent. Following this approach is an effective and a time-saving option when we are working with a dataset with small features. When you have a large number of features, example 10,000, the calculation will take longer than the iterative process with gradient descent. To improve the quality of the normal equation algorithm, features should be regularized and redundant features deleted. The method of identifying similar groups of data in a dataset is called clustering. In simple words, the aim of clustering is to segregate groups with similar traits and assign them into clusters. Clustering can be divided into two subgroups. Hard clustering. In hard clustering, each data point either belongs to a cluster completely or not. Soft clustering. In soft clustering, instead of putting each data point into a separate cluster, a probability or likelihood of that data point to be in those clusters is assigned. There are many clustering algorithms. Here are the top 5 clustering algorithms that a data scientist should know. K-means clustering. Mean shift clustering. Density-based spatial clustering of applications with noise, scan. Expectation, maximization, M, clustering using Gaussian mixture models, GMM. Agglomerative hierarchical clustering. K-means is one of the simplest unsupervised learning algorithms that solve the well-known clustering problem. The procedure follows a simple and easy way to classify a given dataset through a certain number of clusters. K-means algorithm starts with a first group of randomly selected centroids, which are used as the beginning points for every cluster, and then performs iterative or repetitive calculations to optimize the positions of the centroids. Unlike the popular K-means algorithm, mean shift does not require specifying the number of clusters in advance. The number of clusters is determined by the algorithm with respect to the data. Given a set of data points, the algorithm iteratively assigns each data point towards the closest cluster centroid. The direction to the closest cluster centroid is determined by where most of the points nearby are at. So each iteration, each data point will move closer to where the most points are at, which is or will lead to the cluster center. When the algorithm stops, each point is assigned to a cluster. Unlike K-means, there are no centroids in BSCAN, and clusters are formed by linking nearby points to one another. TPS can require specifying two parameters which influence the decision of whether two nearby points should be linked into the same cluster. These two parameters are a distance threshold, epsilon epsilon, epsilon, and min PTS, minimum number of points. K-means runs over many iterations to converge on a good set of clusters, and cluster assignments can change on each iteration. TPS makes only a single pass through the data, and once a point has been assigned to a particular cluster, it never changes. Also called a bell curve, sometimes GMM assumes all the data points are generated from a mixture of a finite number of Gaussian distributions with unknown parameters. One can think of mixture models as generalizing k-means clustering to incorporate information about the covariance structure of the data as well as the centers of the latent Gaussians. Agglomerative hierarchical clustering is a clustering algorithm that builds a cluster hierarchy from the bottom up. It starts by adding a cluster for each of the data points to be clustered, followed by iterative pairwise merging of clusters until only one cluster is left at the top of the hierarchy. The choice of clusters to merge at each iteration is decided based on a distance metric. Some of the most popular applications of clustering are recommendation engines, market segmentation, social network analysis, search result grouping, medical imaging, image segmentation, anomaly detection. An example is a particular instance of data, X. We put X in boldface to indicate that it is a vector. We break examples into two categories. Labeled examples. Unlabeled examples. A labeled example includes both feature, S, and the label. Each piece of that unlabeled data includes some meaningful tag, label, or class. For example, labels for the above types of unlabeled data might be whether this photo contains a horse or a cow, which words, and so on. Unlabeled data consists of samples of natural or human-created artifacts that you can obtain relatively easily from the world. An unlabeled example contains features but not the label. Some examples of unlabeled data might include photos, audio recordings, videos, news articles, etc. There is no explanation for each piece of data. It just contains the data, and nothing else. Logistic regression is a statistical method for analyzing a dataset in which there are one or more independent variables that determine an outcome. The outcome is measured with a binary or dichotomous variable, in which there are only two possible outcomes, point 1, true, success, pregnant, etc., or 0, false, failure. For example, we might use logistic regression to classify an email as spam or not spam. In order to do machine learning, there should exist a relationship or pattern between the input and output values. Machine learning algorithms try to guess a hypothesis function h, x, that approximates the unknown. The goal is to find the final hypothesis that best approximates the unknown target function. A decision boundary is a hypersurface that partitions the underlying vector space into two sets, one for each class. A general hypersurface in a small dimension space is turned into a hyperplane in a space with much larger dimensions. Decision boundaries are not always clear-cut. That is, the transition from one class in the feature space to another is not discontinuous, but gradual. An artificial neural network, AN, is an information processing paradigm that is inspired by the way biological nervous systems, such as the brain, process information. It is an interconnected group of nodes, akin to the vast network of neurons in a brain. Unlike conventional programming approach where the computer follows a set of instructions in order to solve a problem, the way of problem solving must be known and stated in small unambiguous instructions. Neural networks liberate itself from the approach by opting to process information in a similar way the human brain does. They cannot be programmed to perform a specific task but learn by example. Components of neural networks. An input layer, X. An arbitrary amount of hidden layers. An output layer, Y. A set of weights and biases between each layer, W and B. A choice of activation function for each hidden layer. Neural networks work takes several input, processes it through multiple neurons from multiple hidden layers and returns the result using an output layer. This result estimation process is technically known as forward propagation. We try to minimize the value/weight of neurons those are contributing more to the error, and this happens while traveling back to the neurons of the neural network and finding where the error lies. This process is known as backward propagation. Single-layer perceptron are networks which consists of just one unit. It is the simplest kind of neural network which has just one layer in which inputs and weights are fed to get the output. Multilayer perceptron is a network of multiple layers of neurons connect in feed-forward fashion. Thus we come to an end of the initial understanding of artificial intelligence. To understand now the practical approach, we have to use any popular tool such as TensorFlow. Refer the module TensorFlow for the further learning. Thanks for watching the video.